Welcome back. Alright, so in this video, we're going to start to code our enemies. So we want them to move down and we want to detect when an enemy hits the player. Let's start off by dragging and dropping one of the hazards in the scene. We're now going to go inside of the scripts folder and we'll right click and create a new C# script that I'll call enemy. Once the new script has been created, I'll drag and drop it onto the hazard in the hierarchy. Let's now select the hazard, make sure the script is attached to him, and we can now double click on the enemy script to start coding it out. The first thing that we need to do is to define some kind of speed, so we can choose how fast these enemies fall down. So we could just create a simple public float variable called speed, but let's say we wanted the enemy to have a random speed between two numbers that we can choose inside of the Unity Inspector. So we want a minimum speed and a maximum speed variable, and then we'll need another variable called speed that will be equal to a random number between our min and max speed variables. Alright, so pause the video here guys and try to figure out how to do this. I will be back with a solution once you're done. Alright, so I'll start off by creating two float variables, one called min speed and the other called max speed. I will of course make these variables public so that we can tweak them nice and easily inside of the Unity Inspector. We also need a float variable called speed, which will store the random speed of this enemy. So now inside of the start function, I'll set the speed variable to be equal to random.range. Inside of the parentheses, I'll just pass in min speed and max speed. So each enemy will have a random speed between those two variables. Awesome. The next step is to make him move down. For that, we will simply go inside of the update function because we want to move him a little bit each frame. We now just need to write the line transform.translate. Inside the parentheses, we will type in vector2.down multiplied by speed multiplied by time.delta. Okay, so let me explain to you this line. Transform.translate is a Unity function that will move an object around. It's just like taking the move tool and moving him manually in the scene, but in this case we're moving him within our script. Inside the parentheses of this function, we need to specify where do we want to move him and at what speed. So in other words, the direction and also at what speed we want to do so. That is why we are saying vector2.down because we want the hazard to move down. Vector2.down is basically a new vector2 with the x coordinate being 0 and the y coordinate being -1. And then we are multiplying that vector2 with a random speed so that the hazard moves downwards at the correct speed. Okay, so now why are we multiplying our speeds with this time.delta? This is something that you'll see very often when creating games in Unity. Multiplying a speed with time.delta makes our movement frame rate independent. Alright, so don't be scared with the word frame rate independent. It just means that the object that you are moving will move as fast on a new powerful PC or on your grandparents' old computer. Alright, so that is all we need on our enemy script for the time being. Let's now save the script by pressing Ctrl S or Command S and let's head over back to Unity. We are now going to define our min and max speeds. I'll choose for now 15 and 25, but it doesn't really matter because we'll only know what are good values once the enemies are spawning automatically. That is the beauty of using public variables, they are so easy to tweak and so it helps so much when we're playtesting our game. If we now press the play button, you'll see that the hazard is moving down correctly. Awesome. Let's now detect when the hazard hits the player, and we will deal damage to the player if he gets hit in the next video. So if you remember from the video where we coded out the player movements, I told you that to detect collisions between two objects, those two objects both need to have 2D colliders on them, and at least one of them needs to have a rigid body 2D component. The player already has a box collider 2D, and a rigid body 2D, so all we need to do is to add a box collider to the hazards. So I'll select the hazard in the hierarchy, and I'll add a box collider 2D component to him. We then just need to press this button, and we can now move the point around so that it fits the boundaries of the enemy nicely. We don't actually want the player and the hazard to block each other like for walls on the side of the game. We don't want them to have any physical contact and to move each other around when they collide. We just want to detect if the two objects overlap with each other. To do so, we'll just tick the is trigger box on the hazard's box collider 2D components. Let's now head over back to our enemy script. To detect collisions, we'll use the void onTriggerEnter2D function, and as a parameter, it will take in a collider 2D variable called hitObjects. So this is a built-in Unity function that gets called automatically when our enemies collide with any object in our game. Make sure you spell everything just like I did, otherwise it will not work. So now this function, like I said, will get called each time we hit any object in our game. But we only want to deal damage to the player if the player gets hit, right? So the way that we do that is by using something called tags. So if we now go back inside of Unity, I will select the player character and I'll go to the top of the inspector where we have got the tag dropdown, and we'll select the player tag. Now back in our script, we'll just check if the object that we collided with has the tag of player. So the object that we collided with is stored in the collider2d parameter that we call hitObjects. So inside the function, we will create a if statement with the condition being hitObject.tag is equal to player. Make sure you put a capital P on the word player because that is how the tag is written in Unity. Okay, so the code that we put inside of the if statement will only run if the object that we collided with has a tag of player. For now, let's just print out that we hit the player. Now let's save our script by pressing Ctrl S or Command S. Let's test if the collision detection works correctly inside of Unity. Let us place the hazard right on top of the player, and if we now press the play button, you'll see that the hazard will move down, and if you look inside of the console, you'll see that we successfully detected the collision. Perfect, guys. Alright everybody, so we are making really good progress here. I'll see you in the next video where we will actually deal damage to the player when the enemy hits the player. Alright, I'll see you over there, guys. Good work. Cheers.